Okay, so let's talk about angle measure. So geometry, the first chapter of geometry will talk about the basic concept of what to expect and basic things that we're gonna use for the whole duration of our class. Like the last lesson that we have is distance formula. Distance formula the is a very important lesson that you need to understand and you need to be familiar on how to use that simple formula because we will be using that distance formula in most of the lessons that we will have in this class. Not only that lesson, but it will be a part of the application of the next lessons, and one of it later in 1-6 we will apply distance formula. It's the same thing. I mean, it's the same process that we will use, but we will use it to find out some other things. Okay, so that's distance formula. Okay, I'm explaining this because I said we will be discussing the basic of of geometry, and today this time we'll talk about angle. Okay, so when you hear the word geometry, you always think of figures, right? You always think of like shapes or rectangles, squares, triangles, and that's a really a good understanding of geometry because those are the things that we will be uh, discussing later on, and we'll be discussing their properties, especially their properties. For example, last time we talked about biology in the classroom. For example, human human being. Okay, so when you look at a human being, there's a lot of things that we need to study in that. Although when you are in biology class or if you are health pathway students, you just you learn um, part of it. Unless you go on a medical field later, you become a doctor, then you have to learn the very details of a human being, but still you have to know the basic parts. Okay, like if my memory serves me right, I can remember that we talk about the different systems: digestive systems, circulatory system, skeletal system. Those are just the basic systems in our human body. Okay, now in geometry, on the other hand, in line with geometry, in geometry, we'll only be dealing with two things for every figure. We'll only be dealing with sides and angles. Sides, the sides. The sides are made up of line segment, and that's why we talked about line segment a while ago. We talked about distance formula a while ago, because we're going to apply them later when we talk about sides of a particular polygon. And now, angle. Okay, when we say angle, it's the corner. Okay, if you look at around you, you just focus on the wall or the ceiling. The corner represents an angle. Okay, if you are holding a piece of paper, you bend that piece of paper and then you try to open it. You try to open it, and then you see that there is an angle formed in that particular paper. Okay, so we will talk about angles and sides mostly. So what is an angle? Let's start with array. So array is part of a line, just part of a line. Okay, this is an example of array. Okay, so when you look at this, one is endpoint. It goes to the other end, which arrowhead. So it's like half line segment. You know what's half, right? It's different from half German, half shepherd. Just kidding. Okay, so this is array. One is an endpoint, the other one is an arrowhead. Remember, for a line, when we talk about line, both are arrowheads. Arrowhead, arrowhead. But for the ray, one is line segment, one is an arrowhead. Okay, so this is just one ray. Okay, one ray. We name this ray as ray EG because we use G, and that's or ray EF. Okay, so from one point, we always start with the end point. Okay, when you name array, always start with the first letter should be the letter that corresponds to the endpoint, and then the second letter will be any letter on that ray, as long as you see that the other end is an arrowhead. Okay, so you can name it as ray EF or ray G. Okay, but note, but not as FE, ray FE, because F is a point and you're going on another endpoint. So that is, if you want just EF, it can also be line segment EF. Okay, but not ray symbol on top of F and E. So there's a symbol that you have to write on top of the two letters when you name a ray, and that symbol is a line with an arrowhead on the right end. You cannot interchange the direction of the arrowhead and then switch your endpoint and other point. It's always like that. Okay, so now opposite rays. So for example, this line here represents two opposite rays. We have ray PR and ray PQ. They go on a different direction. That's why we call them opposite rays. So an angle is formed by two non-collinear rays. So that's the time. If you have a ray that is not forming a straight line, then that's clearly representing an angle. So for example, here you have a ray AC and ray AB. They have a common point A, so therefore we form an angle over here. We have an angle over here. So the symbol for angle is this, like a less than, but the lower part is a straight line, and then you have a diagonal line going to the from the left end going up to the right. Okay, so this can be named as angle A. It can be named as angle BAC or CAB or angle 4. See, there are three ways to name an angle. You can name it by its vertex. Okay, so when we say vertex, that's the common point. The corner, the tip of the angle, that's the vertex. Okay, this is a vertex. There's no other tip because this goes to another direction, this goes to another direction. They meet over here. This is the corner, so that's the vertex. You can name it by the vertex. You can name it by the number assigned to the vertex, closer to the vertex, or most specific way to name an angle is to name it using three-letter combination. Okay, like you see there, angle BAC and angle CAB. Okay, when you name it with three-letter combination, you take one letter from this side, use your vertex, and get another letter from the other side. Okay, notice that in this kind of angle, both names have the center. Why is that so? Because A is the vertex. If A is not at the center, you're referring to another angle which is not this one. Okay, so in this angle, your vertex is A, therefore A should be at the middle of the two letter. The first and the third letter does not have a restriction on who is the first, who should be the third. The only restriction is you make sure that the middle letter pertains to the vertex, to the letter assigned on the vertex of the angle that you are naming. Okay, so an angle is composed of a vertex and side. So you should always have two sides. You cannot have a vertex. You cannot have an angle if you only have one side. You cannot have a corner in the house if there's no other side in your house. Okay, so you always have two sides. So when you name this side, when you look at this angle, this side is a ray, so ray AC or side ray AC. This side is ray AB. And vertex is a point, and then when you name a vertex, you name how you name it like how you name a point. So vertex A, capital A. Okay, you see there's a consistency from our first lesson. From the first lesson in geometry, when you name a point, always capital letter. Not just in geometry, that's also the lesson that you have in algebra 1. When you name a point, you always have to use a capital letter. Okay, so we have interior and exterior here. Point A, point D, and point E lies on the angle. Point C and point B are in the interior. Point F and G are on the exterior of the angle. Okay, so we have here, name all angles that have W as a vertex. Okay, now going back to naming of the angles. when you name an angle like this one, angle A, that's good. You can just name this angle here as angle A, but sometimes you have to be very careful. You cannot just name an angle with its vertex because its vertex might be shared with more than two angles. For example, here, W. When you are asked, what angle is this one here? You cannot just say angle W because this one is also using W and this angle here is also using W. So the most specific way to name an angle is to use the three letters or that number assigned to the angle. Okay, so going back to this, name all angles that have W as its vertex. So we can have angle 1, angle 2, and angle 3. Okay, we can name angle 1 as XW, XW. I mean, angle, there's aside from 1, 2, and 3, we also have XWY. That's a combination of 1, Elmora angle 3. We can also have an angle ZW, V. That's a combination of angle 3, Elmora angle 2. We can also have an angle Y, W, V. That's another name for angle 2. Another name for angle 1 is angle X, W, Z. Another name for angle 3 is angle Y, W, Z. Okay, so those are angles that have W as its vertex. The sides of angle 1. So angle 1 is over here. So what makes angle 1? This side and this side. So you name this side as ray WX and this side as ray WZ. Okay, for every angle, you have to have two sides. Teacher, Sebel 3 indiak, only 2 and cannot also 1. It should be 2. So when you're asked for the sides automatic, you have two answers. Okay, next, write another name for angle WYZ. Angle WYZ. So angle W, you start walking from W to Y to Z. Oh, it's just like this is your whole way W to Y. You turn on Y because you're going to Z over here. So you're referring to this angle here, this angle here. So what is this angle? Aside from WYZ, you can name it as angle 4. Hindi ka any angle using Y, so you might as well name it as angle Y. Or you switch the first and the third letter, same. Z, Y, W. That's another name of part of the given name, angle WY, Z. Clear? So angle WY, Z. So there's another name. Okay. So what do we use to measure an angle? We use a protractor. So when there's a protractor, you will see a 0, 10, 20, 30, more 180. Okay, in the other side of that, in the inner circle, you have the opposite. From this side that ends in 180, on other end, on the other side of it, it starts from 0, 10, 20, 30, more 180. Depending on where is your ray, where is one side of your angle lies. So when you measure an angle, you put the protractor on top of your angle, making sure that the vertex is at the center here. Some protractors have a hole, so that means your vertex should be in at the center of that hole, and one side should be aligned to this side of your protractor. Then you read where the other side ends on your protractor. Teacher, is it 120? No, we don't read the 120 because this is where the first side lies. So we read it from the 0. So 0, because if you read it, this is 180. Okay, so this is 0, 10, 20, 30, 40, 50, 60, 61, 62, 63, 64, 65. So 65 degrees. Okay, so there's an explanation around here. Okay, if you do the other side, if the angle is over here, then that's the time you use the inner circle, because the inner circle on this side starts from 0, 10, 20, I'll say 50. Teacher, no more small line. You can use the small line of 15, and over here, then 51, 52, 53, 54, 55, 56, 57, 58, 59, you go back 60. So that's how you measure the angle. Okay. Any question? I cannot hear you also because this is not a live lesson or face or real-time lesson. Okay, angles. We can classify angles. Like you guys, I can classify you as who lives in Koror, who lives in Malacayoc, who lives in Ardmao, who lives in Delilio, like that, based on the home state that you have. So we have to base it on something. If you want to classify, if I say group yourself according to your birthday. Oh, the birthday is your point of classification. So when you classify angle, you can classify it based on its angles, okay? Based on its angle measurement. We have three classification: right angle, acute angle, and obtuse angle. Just now, these are the three basic classification of angles. Right angle is when you have a 90 degrees angle or a square. At school, mangarangi square, understood 90, even if you don't see the number 90 there. The square that you see on the corner is an information, is a symbol that tells you yang angle is 90 degrees. If the angle is smaller than that, then it's just acute, malcute angle. Okay, malkakare angle. If it's bigger than 90, mal a little claw angle. So that's obtuse angle. Okay, obtuse angle. Clear? Okay, so here, measure each angle and classify as right, acute, or obtuse. We don't have a protractor, but let's look at this angle PMQ. PMQ, by looking at it, we say it's acute because it says measure and classify. So you can only answer the classify part because I don't have a virtual protractor that I can put on top of here. So small, PMQ, that's small. So it's obviously acute, like what it says here, acute angle. But its measure is 30 degrees. Okay. TMR, angle TMR. Oh, TM mora R, there's a square making in that connecting the two sides. So that means it's a right angle. And it's not necessary for us to use a protractor. Automatic right angle is 90 degrees. Okay. Now we have congruent angles. We have symbols to tell us nga ringi congruent, and yeah, these are the symbol that we see that small curves on the angle. So it does not tell us the size. It only tells us which to which it is congruent to. So for example, this one, angle NMP has single curve. So this is congruent to another angle that has another single curve, which is angle QMR. Okay, sometimes you see a figure that has some angles has single curve, some angles has double curves, some angles have triple curves. So you pair it to the one which has the same curves on it. Okay, so now let's go to the meat of this lesson, like always algebra. So here, a trellis is often used to provide a frame for vining plants. Some of the angles formed by the slats of the trellis are congruent angles. When we say congruent, they're equal. So in the figure, angle ABC is congruent to angle DBF. So if they're congruent, then they're also equal. So if the measurement of angle ABC is 6x plus 2 and the measurement of angle DBF is 8x minus 4, find the actual measurements of angle ABC and angle DBF. We don't get our protractor and measure there. We don't know if this is properly, if it's the picture is taken right in front or sideways. So we cannot really solve its angle using protractor, but we're given with expressions here. So we'll use these expressions and we'll use the given statement that these two angles ABC and DBF are congruent. Congruent. Oh, that's congruent. So if they're congruent, then their measurement. Now, if you change congruent to equal sign, take note, if there's already equal sign, then you have to put this letter M before the angle symbol. We'll say measurement of angle DBF. You read it as measurement of angle DBF is equal to, like that, or measurement of angle ABC is equal to, like that. So given the solution, given that the two angles are congruent, by definition of congruent, then they are equal. So you see, without M, then and it has, then it all of a sudden it contains M now because we're using equal sign. So this is our equation. So since we have this equation now, we replace this ABC with what is it equal to? It's equal to 6x plus 2. And DBF with what it's equal to, which is 8x minus 4. Okay, so we have 6x plus 2 equals 8x minus 4. Do the algebra. You want to put the x on the other side, on the right side. So that means we need to take out the negative 14 here, and that is by adding 14 on each side. So plus 14 plus 14 becomes 6x plus 16. That it's why 16? Because it's 2 plus 14. 16 equals 8x. No more in the negative 14. That's why we plus 14 to cancel it out to make it 0. We did that one in our pretest. And then minus 6x on both sides. So minus 6x here, that becomes 0. So on the left, it's only 16. And then on the right becomes 8x minus 6x is 8 minus 6 is 2, 2x. Then divide both sides by 2. So x is equals to 8. That's the value of your x. The question is find the actual measurements. Find the actual measurements. So your x, the value of the x will lead you to the value of the angle. So we will replace. You have that one in algebra. You call it evaluation. You evaluate. So you replace the x with the value that you have solved. So 6x plus 2. Since the two angles are equal, you can just choose one of them. Okay. So you may use DBF or ABC. So 6 times 8 plus 2. 48 plus 2, it's 50. Okay, since ABC is equal to a measurement of angle ABC is equal to the measurement of angle DBF, and measurement of angle DBF is equal to 50. Both angle ABC and angle DBF measures 50 degrees. Okay, here. Suppose angle JKL is congruent to angle MKN. If the measurement of angle JKL is 5x plus 4 and the measurement of angle MKN is 3x plus 12, find the actual measurements of the two angles. What will you do? And first, we write the equation, follow this one. This one is our mother equation. I cannot highlight it. Then, from congruent, we change it into equal, so it becomes measurement of angle JKL is equal to the measurement of MKN, like here. And then after that, you replace with the expression that represents them. So 5x plus 4 equals 3x plus 12. And then you will do the algebra. Okay? And then you solve for the x. And then after you solve for the x, you replace x to one of the angles to finally answer the problem, which is the actual measurements of the two angles. Okay? We also have what we call angle bisector. So it is not just a normal line in between in a given angle, but when you say bisector, it cuts into half. Okay, a ray that divides an angle into two congruent angles. So we have here angle RPS, and all of a sudden there is ray PQ, which is considered as angle bisector. Or if it's not given to be an angle bisector, it will be considered as an angle bisector if you see that that line produces two equal angles on both sides of it. So there's a single curve here, narabitang, there's another single curve. So that means RPQ is congruent to angle SPQ. Angle RPQ is congruent to angle QPS or SPQ. And that means this line separating the two angles can be considered as an angle bisector. So if that's the case, in Then you can also say measurement of angle RPQ is equal to measurement of angle QPS. Okay, but if it's not an angle bisector, we go back to the basic. We have a basic rule in geometry. The sum of the parts is equal to the whole. If, let's say, these two angles are not equal and you're facing a problem with this, the equation that we can write here is, let me see if I can. Where is that? Annotate. The equation that you can write is this one. You see that? Measurement of angle R, measurement of angle R, PS is equal to measurement of angle RPQ plus measurement of angle QPS. That's if you cannot, that's if the two smaller angles are equal. So it's just like part 1, RPQ, smaller angle, plus another smaller angle QPS. Together, they make the big angle RP Mora Q. That's a basic way to also construct an equation involving two angles that is sharing a common side. So RPS, measurement of angle RPS is the biggest angle that you have from R to P to S, is equal to the combination of RPQ and QPS. Okay, so that's how we solve angle problems. Okay, so I'll be posting, let me check this one. Okay, so let me check another workbook. Okay, here. So with an example where there's a solution here. Refer to the figure above. If measurement of angle MPN is equal to 2x plus 14 and measurement of angle NPR is equal to x plus 34, find x and the measurement of angle MPR. So we look at the figure. We see that in the figure, there is this small curved on the angle. So the information that it tells us was say, tiang angle, matyang angle are equal o sisiw. So therefore, they're equal. So you put measurement of angle MPN is equal to the measurement of angle NPR. Okay? So from there, you replace what is MPN? 2x plus 14. So 2x plus 14. What is NPR? X plus 34. So x plus 34. So together, your equation is 2x plus 14 equals x plus 34. And then you do the algebra. Minus x on both sides to take out this x here. So that leaves you x plus 14 equals 34. And then minus 14 on both sides. That gives you x equals 20. I don't know if you hear the grass cutting going. Okay. So, and then the question is find the measurement of MPR. Hindi ka MPR telang x makarang plus telang. But when you look at the figure, MPR is a combination of MPN and NPR. So to find the measurement of this whole angle from M mora R from side PM and mora side PR, then we need to construct another equation. Okay, this is a typo error. This should be MPR, not N. So MPR is equals to MPN plus NPR. So that is 2x plus 14 plus x plus 34. And then you replace all the x with 20. So 2 times 20 plus 14 is 54. 20 plus 34 is 54. So 54 plus 54 is 104. 8. So this 108 is the measurement of MPR, not N. It's typo error. It's MPR, meaning the whole thing is 108. This is just 54. This is also 54. Okay. So I hope if you try to answer and then solve the classwork, I'll be posting the classwork later in a separate post. Okay. Thank you.